So as our next example, I want to evaluate 1 over z over gamma, where gamma is going to be a circle of radius r centered at the origin. So a circle of radius r centered at the origin. Here r is just some fixed number, so if you want to call it 5 or 7 or whatever, r is fixed. And then gamma is going to be parameterized by the curve gamma of t is r e to the it, and t is going to go from 0 to 2 pi. Okay, so if this is our parameterization, if that's the curve, we want to evaluate the integral of 1 over z dz. And so what we can do is we can just straightforwardly calculate, this is going to end up being the integral from 0 to 2 pi of, let's see, 1 over z is going to be, what we're going to do is we're going to have f of gamma. So we're going to take gamma and plug that in for z. So we're going to get 1 over r e to the it times the derivative of gamma of t. So r is a constant. The derivative of e to the it is going to be I e to the it. So it's going to be r times I e to the it dt. And then the e to the it's just cancel. The r's just cancel. We end up with the integral of I from 0 to 2 pi. I is a constant. So this is just going to end up being 2 pi I. Okay, so this is an example that we'll talk about very soon. Let's do one more. Let's also evaluate the same integral. So 1 over z over what I'm going to call minus gamma. And so what that's going to be is that's going to be the same curve except oriented backwards. So instead of going counterclockwise, we'll go clockwise. So this is going to be the same curve. Oops. So this is going to be the same curve, just oriented the other way. So we're going to orient this so that this is going counterclockwise. I'm sorry, so it's going clockwise. So here gamma is going to be still r e, I guess it'll be to the minus it. And our t is going to go from 0 to 2 pi. All right. So let's see what's going to happen. It's going to be basically the same. It's going to be the integral from 0 to 2 pi. 1 over z is going to be 1 over r e to the minus it. The derivative will be very similar. This will be r times minus I e to the minus it dt. And again, the exponentials cancel, the r's cancel, and we end up with minus I, so it's going to be minus 2 pi I. And it turns out that one feature in general is for functions that are integrable, where gamma is a piecewise smooth curve. If you integrate a function over this curve gamma, but then you change the orientation, so you make it minus gamma, this is going to be minus the integral of f over gamma. So here, gamma is the parameterization of some curve. So gamma is the parameterization of some curve. And minus gamma, let me actually say it a little bit better. Gamma is not the parameterization. Gamma is, let's just making this more complicated than it needs to be. Gamma is some curve, okay, with some orientation. Minus gamma is the same curve, just oriented in the opposite direction. So oriented in the opposite direction. And it turns out that this is kind of like when you flip the bounds for integration in Calc 1, you got a minus sign. Well, here we're just reversing the order of we're just reversing the orientation of the path. Okay, so oriented in the opposite direction. So it turns out if you reverse the orientation, you got a minus in the integral. Okay, so in the next video, let's talk about some general properties that these integrals that they have.